Welcome back, Team Rivan. Since the topic of your day 2 involves subnetting, for this assignment, we will be designing networks and configuring them in RSD-Hayop. Now, before that, let me show you the two more recent tools that you can use to study subnetting. So, I'm pretty sure this was shared to you during class, but I'll showcase it here anyway. So, we sent to you the generate CIDR questions. And if you don't know yet how to use this, there's two ways. You can either run this exe file, so that's the simpler one, although your computer may show a warning, mainly because there is a requirement where it writes files on that exact same directory. So that's the only reason why there's a warning. Or you could always run it via the Python file. So how to run it via Python file? Inside this directory, inside the py directory, what you can do is you can select the path file here and then enter cmd and then press enter. And then you're going to be sent to the exact same directory on cmd, and I'm going to type dir. And if you have Python installed, you can just type Python and then the file name, which is called gen_hw.py. gen_hw.py, which is the file name for the Python file. And then enter. And that way, it's going to run the script and generate its own test answers and test.json files. So that's all it is. Let's go check the contents of these files. So in test.json, open it with Notepad++, preferably Notepad++ or VS Code, just not ordinary Notepad because everything is written in JSON format. In fact, let me show you what it would look like on ordinary Notepad, although I don't think I have it available. Where is it? Here it is. So this is what it would look like. Although I guess it's not too bad, but it's always nice to have a little bit more colors to work with. But anyway, let's go back here. So this is the CIDR, generate CIDR questions. It's the one that's been discussed in class. Basically, there's like 4 sets of it. So here's the first 3. In this question, or in this portion, CIDR is given. You need to determine the subnet mask, the Rivan format, and the wildcard. In the next set, the subnet mask is given, so you'll need to determine the CIDR, the Rivan format, and the wildcard, and so on. So it's basically the same thing that you've done in class, but this time, it's randomly generated. Every time that you run that exe file, it's going to generate completely new copies or completely new questions. So like for example here, the first question is /15. If I run the exe file and then go back here, it said it updated. So let me try to reload it. Yes, and there we go. So the values changed. Every time that you run this, it's gonna change values. So that's all it is. And then once you've done answering this entire thing, you can check the test answer portion. And there we go. So it's just a way to verify if all of your answers are correct. Okay? So let me close that. So next up, that's it for generate CIDR questions. Let's move on to the subnetting questions. So just like before, there is a Python file that you can run. It's called main.py, or you can run the exe file, main.exe. Let me delete these existing documents and then run main.exe. And there we go. Oh, and if you're wondering, like, is there a virus? The answer is no. That's why I included the Python file, just so you can see the source code. So there's no virus, I'll vouch for that. Okay, And the only reason why Windows is warning you is because any kind of exe file that tries to write anything on your directory, like this, creating files like this, Windows does take precaution on that. So that's the reason why it does warn you. But all it is for your subnetting questions. So, like for example here, let's work with subnet via host first. And here it is. Now, I'm not going to show you how to answer this, but I will answer it anyway. I'm just not going to explain it because like it was already explained in class and we'd be wasting too much time on that. But anyway, here it is, a scenario, and then the instructions on what you have to do for this network. So we have 27 as the host, or at least the number of hosts. And then you're going to convert 27. So how much is that, or how many bits is that? That is 5 bits. You're going to subtract that. So 5 bits subtracted by a slash 32. That's what? A 27, right? Yes, that is a 27. So that is going to be a slash 27. And then the octet and I, that's a fourth octet. And then it's going to be 32i. And what are we going to do? We're going to put 32 on the fourth octet, which means 192.168.119.224 is going to become 192.168.119.224 plus 32. That's going to be 56/27. Oh, not 56, but 256. There we go. So 224 plus 32, 256. But wait, there's no 256 in an IPv4 address. So that's going to be 120. We're going to carry over from 119 to 120, and this thing is going to go back to 0. So this is going to be the network that we're going to work with. And then the network IP, same exact IP, let me just paste it here, /27. You should know how to convert that. As for the valid range, preferably you get the next IP, or the NOT network. So that's going to be 120.32. And same exact slash. And then the plus minus thing, this is going to be 192.168.120.1. And then just going to subtract 31. And then finally, you're going to subtract once more to 168.120.130, or just 30. Okay, so that's it. This is my answer to this question. Let's check that if that's correct. We're going to go to the answers portion and let's compare. Did we answer this correctly? 5 bits, correct. A/27, good. Fourth, 32. And then the network is 120.0/27. And then all the values for that network, first valid IP, last valid IP, everything is correct. And that's it. That's how you get your answers. Now, let's not leave it there. There's also a part where it says design and implement. So we will be implementing this in RST Hayop. And it's already telling you where you should implement it. So it says this right there. D1 must be the DHCP server and P2 is the client. So let's go ahead and configure. Now, I do know the answer is already in the answers portion, although I would highly recommend to you to not look at the answers portion. This is designed in a way for you to practice not just computing, but also configuring. So let's configure it based on the instructions. So which one are we going to work with? D1, that's the DHCP server. And then the client is P2. So let's go to D2, or D1 I mean. So let's pretend I'm on D1, okay? So first command, config T, and then I'm gonna type this in a way as if I was typing it on the terminal. So first off, we've already done this. Reserve the first two IP addresses, that's good. Set the network for VLAN 69, okay. As far as I know, VLAN 69 does not exist, so we will need to create it. So VLAN 69, give it a name. Let's assign a name of concentrics. So let me just put concentrics there. And then exit so that our VLAN is applied. Then let's assign an SVI. What will be the IP address of concentrics on D1? D1 must be the DHCP server. It's not assigned here, but for now, let's say that the IP is going to be the first valid IP. So we're going to put 192.168.120.1 with a /27, no shut to turn it on, and then exit. There we go. And then let me zoom in a bit more. And what other requirements do we have? Reserve the first two IP addresses. Okay, that's an exclusion right there. And that's about it. So let's do an exclusion. IP DHCP excluded -address. And we're excluding the first two, so that's going to be 192.168.120.1 to 192.168.120.2. That's it. And then for the DHCP pool, it was not specified, so we can call it whatever we want. I will call this concentrics pool or whatever. Next, within that pool, we need a network. So the computed network, or the network that we've computed, just put it here with its appropriate subnet mask. Okay. Next, default gateway, default -router. For now, it was not assigned, so we're going to assign it the first valid IP, which is the IP address of D1. Then again, since D1 is the core switch or the distribution switch for this topology. And then, let's add a domain name, domain-name. Let's just call it concentrics.com. As for DNS-server, for the DNS server, let's just assign it with the exact same IP as D1 again, and then end. There we go. Next up, the client is P2, but wait, we need to put P2 in the correct VLAN. So go to A2, and we're gonna switch port, interface E1/0. So switch port, mode access, switch port, access, VLAN 97, and then end. Oh, and don't forget to create the VLAN. So VLAN 97 over here, exact same name, concentrics, and then exit. I can't remember if VTP is enabled, so just make the VLAN anyway. And then finally, go to P2. We're gonna make it a DHCP client. So int E1/0, no shut, IP add DHCP, end. Let's do a do BP, or just show IP in brief. Pipe exclude unassigned. Alright, so if my configurations are correct, P2 should receive an IP. So let me go ahead and access D2, or D1 I mean. Was it D1? Yeah, it was D1. So let me copy paste configs for D1. Paste. There we go. Configs for A2. Paste. And finally, P2. And there we go. Now we gotta wait and see if P2 receives an IP address. And there it is. I've got an IP and my configurations were correct. Now you can go ahead and check the answers portion if your configurations match. And don't worry too much about the additional config. So in this case, there's no DNS server, so you don't have to add that. As I said before, in I think it was the previous video, this is all you really need to configure DHCP. But based on the requirements, let's include the domain name anyway for this. So yeah, all the configs matched. And that's it. That's the configuration. And your assignment is going to be you generating one of your own host config. And then let's check. Let's run through another one. Oh, and there we go. A new set, and this time instead of P2, this one is for P1 with a completely different VLAN, completely different network, and a different requirement. Okay, so try that out on your free time. Let's move on to subnet via subnet. I know it's a bit weird, but whatever. Let me open this. Okay, so for subnets, this is what we're going to work with. You need R4, R3, R2, and R1. So we need to enable those devices. I did not enable them on my end, so I'm just going to turn them on. There we go. I'm going to connect to them. That's 9, 10, 11, and 12, I think. There we go. So the instruction says design 6 offices for Accenture using this network and maximize the number of IP addresses. And then for the second, third, fourth, and fifth office, assign first valid and last valid IPs on specified interfaces. So let's compute. So just like before, I'm not going to show the process, or at least I'm not going to explain it too much, but it's overall the same. So 6 offices, how many bits is that? That is going to be 3 bits. Okay, 3 bits. And then A for add, we're going to add 27 with our 3 bits. So that's going to be A/30. Okay, and then convert the 30 to the Rivan format. That's on the 4th octet with 4i. And then the letter I, we're going to map out the offices starting from the first. The first office is 192.168.89.64/30. Then let me just copy paste this. Okay, so for the second office, it's going to be 68. For the third office, that's going to be 72. And then the fourth office, this is going to be a 76. And then finally, the fifth office, is 80. There we go. Let's add in the 6th one, although this is not necessary, but I'm just going to add it anyway. This is going to be 84. Now we're just going to do the exact same thing as we did in the previous one, the host portion. We're going to find, no, don't do that. We're going to find the first valid and the last valid for each network. Although I think it's very obvious, especially using a /30. It's going to be 192.168.89.65 as the first one. And then the next one is going to be 89.66. There we go. So that is the first. Wait, do I need the first? No. They always leave out the first one. So I'm just going to skip here. This is 69 and this is 70. This is 73 and 74. This is 77 and 78. And then 81 and 82. There we go. So I got my first valid and last valid IP, which I am going to assign to these interfaces. Now, if you return to your RSD HIUP, there's more tabs here. The one we're working with, or at least the one that we've been working for the host portion is this. So that's the EIGRP portion of the topology. Next, this is the one that we're going to work with for the subnets. So this is the connection between R4 and P1, which is conveniently over here. So we're just going to apply them. First valid on the routers, last valid on the endpoints. So let's do that. So more configurations. What would you type on the devices as if it were on the CLI? So in R4, config T, int E0/1, no shut, IP add, what was it? First valid. Okay. First valid IP is this one. And then A/30, /30. And then that's it. Next, P1, config T, int E0/1, and then the last valid IP. I'm just going to copy paste it. .70. And then end. Now, I'm not going to show you the entire thing. Like, it's just going to be repetitive. But this is basically what you're going to do. So let's try this out. Let me go to R4 and paste this. And this is going to be on P1. Okay, so to prove that your computation is correct, in order for these guys, or in order for your computation to be correct, these two should be pingable. They will not be able to ping each other if they're off completely different subnets. So if your computation is correct, and this is the first and last valid IP for their network, they should be able to ping each other. So on P1, I'm going to ping this IP. That's on R4. Ping that IP. Enter. And there we go. Success. That means my computation was correct. Therefore, so will the rest. Although I'm too lazy to continue that. So that's something for you to do. But anyway, that's about it for your assignment for your day 2. And hopefully, well, okay, end goal is you gotta be faster, okay? Like, the exam, what is it, like 170 minutes if you're outside of the US, so a bunch of computations. You want to be, like, really fast here. So this is something for you to practice. So go ahead, and yeah, that's about it.